Moments and center of mass. Many objects behave as if their masses are concentrated at a single point called the center of mass. Suppose we toss an object, it might twist and turns, but its center of mass traces out a parabolic trajectory. To understand the center of mass, suppose we have two objects, or in this case, a cat and an elephant, and we put the two on a seesaw. The objective is to balance them. Where should we put the center so that the seesaw is balanced? This location is called the center of mass. To do this, we set up the coordinate system. The center of mass is called x bar. x1 and x2 are the locations of the cat and the elephant. d1 and d2 are their corresponding distances to the center of mass, and m1 and m2 are their corresponding masses. It must be true that m1 times d1 equals m2 times d2, but d1 is the directed distance x bar minus x1, and d2 is the directed distance x2 minus x bar. Distribute this, we have m1 x bar minus m1 x1 equals m2 x2 minus m2 x bar, and we isolate the terms with x bar and move them to the left-hand side. We then factor out x bar because we are interested in what x bar is. X bar times the quantity m1 plus m2 equals m1 x1 plus m2 x2. Therefore, x bar equals m1 x1 plus m2 x2 divided by m1 plus m2. The denominator m1 plus m2 is called the total mass. Each of the terms in the numerator, m1 x1 and m2 x2, is called the moment. X bar is called the fulcrum. m1 x1 and m2 x2, the moments, are measured from the y-axis. x1 is the distance from the y-axis, and x2 is the horizontal distance from the y-axis. Their sum, mi/xi, is called the total moment of the system about the y-axis because each of the xi is measured from the vertical y-axis. This is denoted as capital M, Y, just to remind us that these are computed from the y-axis. Thus, the moment about the x-axis m sub x is measured by the mass times the y coordinate, which is the mass times the directed distance from the x-axis given by the y-coordinate. This is also why it is called the moment about the x-axis, even though we're using the y-coordinate. M sub y is the moment about the y-axis, which is the mass times the x-coordinate. This is the mass times the directed distance to the y-axis given by the x-coordinate. Moments are additive. That means the moment about the x-axis is the sum of each of the moment, and each of the moments is mi, yi. Thus, mx equals m1 y1 plus m2 y2 plus ... plus mn yn. This is the sum as I go from 1 to n of mi, yi. The moment about the y-axis is m1 x1 plus m2 x2 all the way to mn xn. The total mass is m1 plus m2 plus all the way to m sub n, which is the sum as I go from 1 to n of m sub I. We know from the system we set up earlier that x bar, the fulcrum, is the total moments divided by the total mass. The total moments is the sum of mi/xi, and the total mass is the sum of mi. In the two-dimension or in the two-coordinate system, x bar is therefore the moment about the y-axis divided by the total mass, which is the sum of mi xi divided by the sum of mi, and y bar is the moment about the x-axis divided by the total mass, which is the sum of mi yi divided by the sum of mi.